Hi, I am Sri Ranjani Ramkumar from Product Marketing team here at MathWorks, and welcome to this video on getting started with digital input-output for Renesas RH850 Microcontroller using Simulink and Embedded Coder Support Package for RH850 Microcontroller. Microcontrollers include several on-chip peripherals such as DIO, ADC, PWM, timers, and communication interfaces. In this video, let's explore the digital input-output or DIO in short. For RH850 microcontrollers, Simulink provides a rich set of DIO blocks including DIO channel read and write to access individual pins, DIO channel group read and write to work with consecutive pins, DIO port pin read and write to access an entire port at once. In this video, we will narrow our focus to the DIO channel write block and demonstrate its configuration using a classic LED blinking example. The overall workflow for this demo consists of 4 steps. Model the LED blinking behavior in Simulink, configure DIO peripherals using DaVinci Configurator or any third-party MCAL configurator tool, generate and import the CDF file into Simulink, build, deploy and run the model on RH850 U2A Starter Kit. Let's begin with the hardware connection. Connect the RH850 Starter Kit to the Renesas E2 emulator, power the board using 12-volt adapter, connect the E2 emulator to the host computer where the MATLAB is installed using an USB cable. Having the hardware connection done, let's move to the Simulink modeling. I have a blank Simulink model opened. Once you have the hardware support package installed for Renesas RH850 microcontroller, you would be able to see the peripheral blocks in the library browser. Drag and drop the digital channel write block into your canvas and a pulse generator block. Open the block parameter of pulse generator by double-clicking on the block. Set the period, pulse width and sample rate. These settings are essential to generate a pulse. Since the pulse generator is connected to the digital channel write block, which should be configured to control the LED will blink at a specific interval. In this case, for every 1 second. Moving on to the block configuration of the digital channel write, mention the channel identifier name exactly as you would be mentioning in the DaVinci configurator. You can use get DIO channel to get a list of available DIO channel once the CDF is included. Let's come back to this again once we have the CDF. Having configured the block parameter, now open the configuration parameter by pressing Ctrl E and configure the model for your hardware so that the model is built and generates code tailored for the RH850 microcontroller. Go to the Hardware Implementation tab, select the board and device series. To set up the peripherals of RH850, let me import the default CDF that's provided by the HSP for RH850 U2A. The default CDF has DIO, GPT, MCU and port modules configured to initialize the board with necessary clock settings and port and channel configuration that's required to make the LED blink. By clicking on import and selecting the CDF, that is this ARXML file, you'll be able to see the default CDF imported in the working directory and the path is added to the configuration parameter. Though the default CDF is sufficient for the LED blinky demonstration, let me walk you through the DaVinci configurator setting. You can use any of the MCAL configurator tool to configure the MCAL peripheral. In this case, I am using DaVinci configurator. Create a new ECU project in the DaVinci configurator and import the default CDF from the MATLAB working directory. Open the project settings. Under modules, you will be able to see that default modules are added to the project. You can add more modules if required, but these 4 modules are mandatory to build the model for code generation. Now go to the basic editor and configure the pin 6 of port 6, which corresponds to the user LED 6. So let's configure the port 6 as an output port. Now let's configure the DIO module. To configure the channel for the corresponding port, add DIO port container if needed. By default, DIO port container is added and configured for port group 6, under which you can configure the channel or pin from 0 to 15. Now to configure a channel, add a channel container. By default, a DIO channel container is added and configured for the channel bit position 6. Thus, we have configured channel 6 of port 6 as an output pin. Once that's done, I'll export the CDF. Even though I haven't made any changes to the default CDF in this example, I'll export it and bring it back to the Simulink model to show you the workflow. This way, you will know exactly what to do when you make changes to the CDF and need to add it back to the Simulink model. Coming back to the Simulink configuration parameter, browse to the location where you have exported the CDF to include into your model. Moving on with the further settings. Navigate to the code generation tab. Under report, enable create code generation report and open report automatically. Then under advanced parameter, enable code to model and model to code traceability. This traceability allows you to understand how the generated C code maps back to the corresponding Simulink blocks. Click on apply and OK. Let me quickly save the model. With the hardware board selected in the configuration parameters, a new hardware tab appears in Simulink, displaying the selected hardware board, denoting the model is being configured for the selected hardware board. With the CDF now integrated into the Simulink model, let's briefly recap the configuration of the digital channel write block. Open the block parameter and select the Get DIO channel to view the list of DIO channels available from the imported CDF. From this list, choose the appropriate channel to complete the block configuration. With everything configured, click Build, Deploy and Start. This builds the model, generates code and deploy your model onto the microcontroller, allowing you to see the LED blinking. Also, the code generation reports open automatically where you will be able to locate the generated code in the file name led6blinky.c, which corresponds to your Simulink model name tailored for Renesas RH850 U2A hardware. This file contains three main functions: an initialization section that executes once at the start, a step function that runs continuously in the loop, and a terminate function that executes at the end. Additionally, the report provides direct links to the Simulink blocks. And that's it. You have learned how to use the DIO channel write to control the digital output on the Renesas RH850 U2A using Simulink and embedded coder support package for RH850 microcontrollers. Thanks for watching this video.